advantages and limitations. This linear programming problem. By this time, you would be knowing about the linear programming problem. In the business world, resources like time, money, labor, and materials, they're all always limited. The goal of management is to get the best possible result from these limited resources. This is where linear programming comes in. What is linear programming problem? It is a mathematical technique used to determine the best outcome, like maximum profit or minimum cost, in a mathematical model whose requirements are represented by linear relationships. It is essentially the gold standard for resource optimization. Let us discuss about the general formulation of the linear programming problem. In this slide, I have not mentioned the entire formulation. I have just used the keywords, and I'll explain the formulation and explain the words or the keywords that are used in LPP formulation. Decision variables. What are these decision variables? These are those variables which we decide upon to how much of each has to be produced or has to be sold, etc. And they are unknown variables. We will not be knowing the value of these variables. These are the things we need to decide on, like how many units of A to be produced and how many units of B to be produced. Next is the objective function, a mathematical expression we want to optimize. It is either minimizing the cost or maximizing the profit. Constraints, the rules or limits of our system. These are equations or inequalities representing limited machine hours, raw materials, or the budgets. Okay, if it is production of product, number of units of production of product A and product B, then we would take raw materials as a constraint, or we would take the machine hours as a constraint. Non-negativity restrictions. We cannot produce a negative number of products, hence X or Y will be a non-negative number. So this is how an LPP will be formulated, and now we will discuss about the application of an LPP model. Where is this model used? Is it used everywhere, or we say it's everywhere? In production management, in diet problem, in transportation problem, in media selection, etc., in inventory management, in assignment problem, and so on. So let me explain you in detail about the diet problems, about the assignment problem, about the inventory management, and about the assignment problem. In diet problem, it is the problem is to optimize the nutritional constraints, which is a classic example of constant optimization problem. Say, for example, a hospital or a school cafeteria needs to provide a meal that meets all nutritional requirements like protein, vitamins, calories, while keeping the total cost as low as possible. We have several ingredients like rice, dal, eggs, vegetables. Each ingredient has a different cost and a different nutritional profile. Like how much protein per gram. How to use the OR model here? The model sets the nutritional requirements as the constants and the cost per ingredient as the objective function. It proves that optimization isn't just about making money, it's about meeting quality standards at the minimum possible expenses. Now, let us take an example application of the model in the assignment problem where maximizing human efficiency is involved. Organizations often face the task of assigning n jobs to n workers. The goal is to maximize total productivity or minimize total time taken. Each worker has different skill levels for different jobs. If you assign worker A to job 1, they might be fast, but if you assign them to job 2, they would be slow. You create a matrix of cost or time, the over algorithm where here under assignment problem a Hungarian method is used to calculate the unique combination which ensures every job is completed by the most suitable person. It removes personal bias from management and ensures that the human capital of an organization is utilized where it creates the highest value. Likewise, if you take an inventory management problem, the economic order quantity is the model that could be used here. Businesses lose money if they hold too much stock due to storage cost or too little stock due to lost sales. There is a conflict. Ordering in bulk reduces shipping cost but increases holding cost. The EOQ model uses calculus based optimization to find the sweet spot, the exact quantity to order at one time that results in the lowest total cost, that is, shipping plus storage. It is the mathematical secret behind why retail giants can keep shelves full while keeping their warehouses lean. Likewise, the OR model also could be used for media selection problem, it could be used in transportation problem, and so on. Now let us discuss about the advantages and disadvantages of the linear programming problem. No technique is perfect. Let's look at the pros and cons of the LPP. Advantages: scientific decision making. It removes guesswork and replaces it with logic and data. Resource optimization. It ensures that no resource is wasted, providing the most from the least. Bottleneck identification. The model shows which constraints are preventing you from growing. Say, for example, if you only had 10 more machine hours, how much profit could you make? Limitations are linearity assumptions. The real world isn't always linear. Sometimes doubling the input does not perfectly double the output due to economies of scale. Complexity. For massive businesses with thousands of variables, these models can become computationally intense. Certainty. LPP assumes all parameters like cost or resources availability are known and fixed, while it is rarely true in a volatile real world market. So, LPP is the foundational tool for operational researchers and managers. While it assumes linear relationships, it provides a powerful, actionable homework for planning and optimization. I hope you understood. Thank you for listening. Thank you.